Brooklyn class and happy Monday. Welcome back to Homeschool with Carly. Today is a really special experiment because we are going to do a sink or float activity. We are going to try to see if we can get a paperclip to float. So for this experiment, you only need a couple of materials. The first being a giant tub of water. So I am using a regular plastic Tupperware that I filled pretty close to the top with water, okay? The next materials that you will need are a couple of paper clips and a piece of tissue. Now this is the type of tissue that you would use to blow your nose, not wrap presents with. Although I think you could use either one of those types of paper. So let's get started. So the first thing is we want to see right away, can we make a paperclip float? So I have a paperclip right here. And I'm going to take this paperclip and I'm going to drop it into the water and see if I can get it to float. So I'm going to take you guys with me. So I have our paperclip, all right? And right away, I noticed that this paperclip is shiny and silver, right? So it's probably made out of some sort of metal, right? And it has these weird shaped curves and edges. So the first thing is to really analyze what we're studying because we want to see what could possibly make this or not make this float. So I'm going to try and see if this paperclip can float as is because I think it's a really nice shape. It's pretty flat and I think it might float. Do you? Let's find out. So I'm going to take this paperclip and I'm going to drop it into the water. So right away, I noticed that the paperclip sank to the bottom of the Tupperware. So unfortunately, this first part of the experiment, we learned that the paperclip doesn't float. But we have yet to try something different. So what do you think would happen if I take a paperclip and I lightly place it on the top of the water? Well, let's find out. So I have another paperclip right here, and I'm going to try and see if I lightly place it in the water, if it can float. So I'm going to get a nice good grip on this paperclip, all right? And I'm going to place it into the water. Do you think I can get this to float if I lightly place it in the water? Let's find out. Would you look at that? I'm going to take you guys with me so you can see. Look at that paperclip. It's floating, right? And the other paperclip is at the bottom. So, through this experiment, we learned that make a paperclip float, right? So it floated when I put it in lightly. But wait, this experiment is not over. We have a couple more things I want to try. So, I want to take this paperclip out of the water that I lightly placed in, right? And maybe we want to turn this into a different shape, right? So I have this paperclip right here, which I bent up and I turned it into a shape, okay? So I want to leave one of the paper clips plain the way it is and bend one. So we can try and see if this odd new shape will float. So let's find out. So this is a different shape. We're going to try and place it into the water. Do you think that this is going to float? That's sunk to the bottom. But as we know with science, we can try multiple times, right? Because science is all about trial and error. Let's try 2 more times to see if changing its shape really does affect its floating capabilities. We're going to try one more time. Okay? So I'm going to get a nice good grip. We're going to place it on top of the water. Oh, it almost floated. Should we try one more time? Before we call it a bust, right? And it's okay if you make mistakes. Sometimes things could take 100 tries, but we're only going to do 3 tries for this activity. So, look at that. If you change the paperclip's shape, it can still float, right? But a paperclip can also sink to the bottom if it's dropped into the water. So we're going to talk about that in 1 second. Now remember, I kept one of our paperclips the way it is. We're going to try one more thing to see if we can get this paperclip to float. And as you can see, it took a couple tries after we bent the paperclip for it to float. This is a really hard experiment. So remember, I had you cut that tiny piece of tissue paper, right? So we're going to place this into the water, and then we're going to place the paperclip on top. Do you think that all of this will float? Let's find out. I'm going to bring you guys with me. Make sure my hands are nice and dry. Okay. So we have our tissue paper. I'm going to drop it into the water. Okay, so I can show you guys. The tissue paper is floating in the water, right? So now I'm going to try and take this paperclip and place it on top of that tissue paper. Do you think the tissue paper is going to be able to hold this heavy paperclip? Remember how hard it was to get the paperclip to float when we changed its shape and did all those things? It's not an easy task. So imagine placing this on a tissue paper. What do you think's going to happen? Let's find out. I'm going to get a good grip on our paperclip. I'm going to place it on the paper. So I'm going to show all of you. The paperclip is actually floating on the tissue paper, right? So what's happening? This is crazy. Now, it's amazing to think that we could get the paperclip to float in the first place, then change its shape and got it to float. But what we didn't do is get it to float when we dropped it from the top. So why did that happen? Well, when you drop something, right, from the top, first of all, there's upper air pressure, right, pressing downwards, and there's gravity pulling it down, right? So when you drop something and it hits the water, it's hitting the water with a much heavier force, right, than when we place it down. Now, we learned in previous videos way back that there's something called water tension. And water tension is this ability to allow things on water to float. Remember when we put pepper on the water and we broke that water tension by placing soap? And then all the pepper spread out, right? Because it can only float on water. It can't float on soapy water. Well, when we put the paperclip into the water gently, we were able to capture that water tension, right? Because we lightly placed it on top and then it was able to float. However, when we dropped it, it sank to the bottom because it was breaking through that water tension because there was too much pressure from the drop. And this, right? This is magic right here with the paper. So the paper, this is amazing to me because the paper is loaded with water, which is heavy. It's sitting on top, and the paperclip is sitting on top. Now my question is, if I were to continue to add paperclips on top, would this stay? So I'm going to try and get our paperclips from the bottom without touching this piece of paper and see if we can get 2 more paperclips on top of this paper and it can still float. Because that's pretty amazing, right? Let's find out. So I'm going to go into the water. All right. I have this paperclip and there's one more at the very bottom. Okay. So let's try and see if I add some paper clips to this paper, right? Can this paper hold any more paper clips? What do you think? So, I'm going to add another paper clip, all right? So I'm going to get a good grip of my paper clip. I'm going to place it on the paper. And it's still floating. Do you think if I add another paper clip, it will continue floating? Let's find out. We have this one, right? So I'm going to place this one on top. And it's still floating. That's amazing. But what if I take my finger and I touch it and put pressure? Look at that. Still able to float, right? Only when I really push it down did it sink. That's amazing. That is a really great example of how amazing water tension is. It's really strong. So next time you see a bug walking across water, you're going to give it a lot of credit because that is a cool ability. I'll see you guys on Tuesday. Bye!